All right, let's dive right into this explainer and look at a fascinating new paper that tackles what might just be the absolute biggest hurdle in artificial intelligence today. We're talking about thinking about thinking. This research comes straight from the Yale NLP Lab, and honestly, it represents a massive stepping stone in how we understand our AI counterparts. Now, if you've been following the crazy, rapid advancements in large language models lately, you already know they're doing some mind-blowing things. I mean, we're seeing models pass complex exams, write totally functional code, and generate stunning creative work. But there's this hidden ceiling we're quickly approaching. So today, we're going to break down exactly what that ceiling is and how these researchers plan to shatter it to unlock the next level of AI.
So to really get this paper, we first need to define our core concept here, which is metacognition. It's a foundational component of intelligence, and it essentially functions as your ability to evaluate your own knowledge and your own thought processes. Think about us humans for a second. Our ability to learn effectively, to solve complex problems, make good decisions, or even just communicate with nuance, all of that relies heavily on knowing what we know, and arguably more importantly, knowing what we don't know. The authors of this paper point out that metacognition is increasingly recognized as the absolute cornerstone of a truly capable system. When you apply this to AI, the implications are just huge. Without it, you could have a system that's literally memorized the entire internet, but it still won't understand its own limits. It doesn't know when to hit the brakes, verify a fact, or turn around and ask you for more context.
And this perfectly captures the AI landscape right at this very moment. On one side, current LLMs have made massive, undeniable progress across a really diverse range of real-world tasks. They can synthesize mountains of information in seconds and be deployed across dozens of industries. But there's a missing link. Despite all of this forward momentum, the researchers highlight that it's actually completely unclear what their metacognitive abilities even are. We know they can generate text, sure, but do they know why they're generating it? Are they aware of the boundaries of their own training data? Without that self-awareness, we're missing the essential transparency and reliability that we desperately need if we're ever going to put these models into high-stakes environments. Things like medicine, law, or critical infrastructure.
Which leads us to the million-dollar question posed directly by the researchers. When, how, or to what extent can LLMs exhibit or be endowed with effective metacognitive abilities? And it's not just a binary question of, do they have this right now? The researchers are digging into a much deeper, layered problem. They're asking, hey, will these models just naturally develop metacognition as they get bigger? Or do we have to deliberately build it into them using entirely new architectures? And if we do build it in, how far can we push it? Is there a limit to this self-awareness before we hit another wall? Because at the end of the day, this whole thing boils down to trust. Can we actually trust an AI system if it has no idea what its own blind spots are? That's the core mystery driving this entire research initiative.
To crack this mystery, a really extensive team over at the Yale NLP Lab stepped up to the plate. We're talking about researchers like Gabrielle Kylie-May Liu, Arib Ghani, Jacqueline Liu, Jordan Thomas, Mark Stavers, and Armin Kohan. And the paper submitter John Chi Liu hit the nail on the head when he summarized it. They've created the very first systematic, comprehensive review of the current state of knowledge on metacognition for LLMs. This team basically looked at the glaring gap in the literature and said, okay, it's time to build a definitive roadmap for this uncharted territory. So, rather than just running a single isolated experiment, they did the heavy lifting of gathering the entire state of global knowledge into one cohesive place. They are setting the stage for literally every developer and researcher out there who wants to tackle this problem next.
Moving into Section 2, Mapping the New Frontier, inside the Yale NLP Lab's taxonomy. Let's see how they actually bring order to this incredibly complex space.
What's brilliant here is how the paper breaks down all these recent technical advancements into highly actionable categories. They aren't just philosophizing about self-aware AI, they're handing the community the actual tools to go build it. First up, they cover the methods and benchmarks to measure these abilities, which is absolutely crucial, right? Because in computer science, if you can't measure it, you can't improve it. We need standardized tests for AI self-awareness. Next, they dive into techniques to elicit and improve metacognition. This is all about how we can coax that self-reflective behavior out of the models we already have, maybe through clever prompting or specialized fine-tuning. And finally, they lay out strategies to actually apply metacognition in LLMs. That takes this from a cool theoretical concept to practical real-world utility, giving developers the toolkit they need to integrate these self-aware traits into commercial and open-source models today.
But the authors aren't just dropping these ideas in a vacuum. They are actively taxonomizing this entire emerging landscape. They're taking the absolute chaos of rapid-fire AI research and structuring it into a clear navigable map. And by doing this, their big goal is to drastically advance the reliability of AI systems. Think about how scientific breakthroughs actually happen. When researchers across the globe share a common vocabulary and a highly structured framework for a specific field, innovation just skyrockets. People stop reinventing the wheel and actually start building on top of each other's work. This paper provides exactly that kind of structure, making sure the wider community knows exactly how to build more intelligent, reliable systems without getting totally lost in the noise.
And you can literally see the logical progression they're aiming for here. It's a very distinct three-step pipeline. Step 1, endow LLMs with metacognition. That is the foundational, technical hurdle. If the community can nail that consistently, it unlocks Step 2, advancing the fundamental capabilities and reliability of the models. Because think about it. When a model can accurately gauge its own knowledge, its reliability goes through the roof. It stops making things up or hallucinating and confidently tells you when it needs more context. Which brings us right to Step 3, the ultimate goal, achieving capable, transparent AI systems. It's a direct path from teaching a machine to think about thinking, all the way to creating the kind of trustworthy AI infrastructure that we can comfortably weave into our daily lives and the global economy.
Now, this explainer wouldn't be complete without pointing out that this paper is also an incredible field guide for the future. The authors go way beyond just documenting where the tech is right now. They dive deep into the findings and implications of ongoing research from all sorts of labs. They look at the real-world applications, like how an AI with metacognition could totally revolutionize things like automated scientific discovery or even personalized education by just knowing when a student is getting confused. But what I really appreciate is their intellectual honesty. They very clearly lay out the open questions and the massive challenges still sitting in front of us. Things like the sheer computational cost of running these self-reflective loops, or how tricky it is to stop an AI from becoming overly cautious. Finally, they point out the most promising directions for future work, aiming to spark highly targeted, meaningful research across the whole AI ecosystem.
And that brings us to the end of our journey through this seriously groundbreaking paper. I want to leave you with this final, provocative thought to chew on. How will equipping AI with metacognition change the fundamental capabilities of future systems? If an AI inherently knows its own limits, and it can actually reflect on its own reasoning processes, how does that fundamentally change how you interact with it at work or even at home? If you want to dig into the open challenges yourself and really dive into the deep end here, the authors have put together a fully organized list of papers on the Yale NLP Lab GitHub repository. You can find it at github.com/YaleNLP/LLM Metacognition. It is an absolute goldmine for anyone serious about the future of intelligence. Thanks so much for joining me for this explainer, and remember to keep questioning the capabilities of the systems around you.